What's up, guys? In this video, I want to go over a type of rational equation that you can expect on your test. We all know when a teacher is helping us learn rational equations, we usually start with some basic examples, and maybe we'll get something a little tricky on a quiz or a homework, but then voila, the test comes, and we get something that looks like this. And sometimes this might not look like anything that you have done up to this point. And because there's some variations, you're going to get confused, or you're going to go ahead and make some mistakes. And I don't want that to happen to you if you're taking a test on rational equations, or you have to solve a problem like this. So let's go over how I would approach solving a problem like this, going off of the basic understanding that we know for solving rational equations. The first thing I'm going to do is address this too, because a lot of times when we just have a random number on a rational equation, it confuses students because that's an integer and these are rational expressions or also just fractions. So the first thing I'm going to do is I'm going to rewrite that integer as a fraction. Now at least I'm dealing with fraction, fraction, fraction. I like that because I know when I'm dealing with a rational equation, I want to get rid of the fractions. So if I have all fractions, I at least now know what I need to get rid of. The next thing I want to do is understand, well, how do we get rid of our fractions? We do that by multiplying everything by the LCD. The problem comes into the LCD is not dealing with numbers. We're now dealing with polynomials. But one tip that I've mentioned multiple times in videos before is whenever you have a denominator that is actually already a quadratic, look to see if you can actually factor that down. So in this case, I have an x squared plus x minus 6. Let's see if I can factor it. But I don't just want to factor it like on my own. What the trick is typically one of the other denominators is going to be a factor of that factored polynomial. So if I take x squared plus x minus 6, I want to see, well, let's assume that x minus 2 is a factor of that. What would I need to multiply it by to get my x squared plus x minus 6? Because if x minus 2 is not a factor of this rational equation is going to be even more difficult. And it'd be a really, really hard test question, which is possible. But more likely than not, x minus 2 or whatever denominator you have is also going to be a factor of your non-expanded polynomial. And let's go and take a look. Negative 2 times what is going to give me negative 6? Well, the only option here is going to be a positive 3. See, factoring was pretty easy. Now let's double check to make sure it works. Multiply my inner and my outer. That's a negative 2x. That's a positive 3x. Those add to give me an x. And you can see that, hey, actually, I'm going to prefer to rewrite this in factor form. X minus 2 times x plus 3. Now, it's much easier for me to identify what is going to be my least common denominator. What is going to be the polynomial expression that x minus 2 times x plus 3 evenly divides into, as well as x minus 2, and we know 1 divides into everything. Well, since this is going to be my largest denominator, I need to make sure that x minus 2 divides into x plus 3. So you might be thinking, well, what does x minus 2 times x plus 3 evenly divide into? Itself. So therefore, my LCD is simply just going to be the product of x minus 2 times a x plus 3. So I'm going to multiply this whole equation by an x minus 2 times x plus 3. Because when I multiply each and every single term by x minus 2 times x plus 3, I now can divide my denominator into that, and therefore it's no longer going to exist. So think about it. If I do 5 times x divided by x minus 2 times x plus 3, these evenly divide into that product, right? Because you can think of those as over 1. So therefore, I'm just going to be left with a positive 5. Now here, my 1 just divides into it evenly. So therefore, I'm going to be left with a 2 times x minus 2 times x plus 3. And then here, my x minus 2 divides in with x minus 2. And that's just going to leave me with a x minus 3 times a x plus 3. Now, hopefully with the basic understanding of solving rational equations, you can get to this point. But you can see why this would be a popular test question, because the work has not stopped here, right? We have some expanding we now need to do, and we still need to go ahead and solve for x, right? We got to find the solutions that are going to work here. So the first thing I'm going to do is I recognize this is going to be a difference of 2 squares, so I can expand that rather easily. This one I know is going to be in my expanded form of x squared plus x minus 6. So I'll just go ahead and write that. I'm going to leave the 2 out here just for a second. And now I can distribute this 2, because again, I recognize this is a quadratic. Whenever we're trying to solve a quadratic equation, what do we want to do? We want to get all the terms to the same side and set it equal to 0. Then we can either try by factoring or quadratic formula. OK, so now I got a lot of terms here. I'm going to subtract a 5 on both sides. I'm going to combine my x squareds with my x squared, so I get a 0 is now going to equal to a 3 x squared, that's going to be plus a 2x. And then in here, I'm going to have a negative 26. So I can look into factoring this, but I immediately think about the numbers that are going to multiply to give me 26, and that's going to be a 13 and a 2. And I'm not seeing anything where I could go ahead and do that by factoring. So by just doing some mental checks in my head, I'm not seeing that this is going to be factorable. So what I'm going to refer to now is going to be the quadratic formula. Remember, you can solve any quadratic using the quadratic formula. And a lot of times when you're taking a test, if you immediately see that you have a difficult problem that's going to be factoring, or it's going to take you too long to be able to do it, just resort to the quadratic formula. A lot of students have a lot of practice with quadratic formula, and I don't want you to get stressed out or make mistakes trying to think that everything is going to be factorable. Because a lot of times, guys, quadratics are not factorable. So I have x, which is going to be the solutions, is equal to opposite of b, plus or minus square root of b squared minus 4 times a times c, all over 2 times a. Now remember, these are for the coefficients of your quadratic, so ax squared plus bx plus c. So plugging this in, I get x equals, that's going to be a opposite of b, so that's a negative 2, plus or minus the square root of 2 squared, opposite of b minus a 4 times 3 times a negative 26, all divided by a 2 times 3. Okay, so let's see here. I have a 4 times 3, which is going to be a negative 12, and negative 12 times 26. So 12 times 20, that's going to be a 240. And then a 12 times 6 is going to be a 72. So therefore, I have 240 plus 72 is going to be a 312. And then plus 4 is going to be a 316. So therefore, this is a negative 2 plus or minus a 316 divided by 6. Now I want to be able to see, can I simplify this radical? Well, to simplify a radical, you always want to know what is the largest number that evenly divides into that number, right? Now I know 4 goes into 100 25 times. So therefore, I could say 25 is 100, 50 would be 200, 75 would be 300, and then I have 4 more, so that's going to be a 79. So I can rewrite this as a 316. I can rewrite that as a 4 times 79. Now I can take the square root of 4, which is going to leave me with a 2. And let's go ahead and I'll rewrite it over here. So therefore I have a negative 2 plus or minus a square root of 4 is 2, square root of 79 divided by 6. And now I can rewrite, I can reduce this, I can divide by a 2 on the top and the bottom, and I'm going to get a final answer of negative 1 plus or minus a square root of 79 divided by 3.